You're welcome. You're welcome to this training on Introduction to Statistics and Probability. My name is Aling Emmanuel, and this is my email address, blinga2002ug@yahoo.co.uk, and my mobile number is 0789175 989. Thank you. What is statistics? Statistics refers to the science of gathering information, summarizing, reporting, and storage. Its application has been in manufacturing, development of food products, in the development of computer software, energy, and pharmaceutical companies, among others. There are two types of statistics, namely inferential statistics and descriptive statistics. Inferential statistics is a statistical method for making decisions in the events of uncertainty and variation. Know that we can't tell the future, so the future is uncertain to us, but we can use a statistical method of inferential statistics to predict the future in terms of uncertainty. And we also need to know that in life there is variation. For example, the price of a commodity varies from one value to another. So in order for us to predict such a value, we need to use inferential statistics so that we can be able to ascertain the value in the presence of variations. Whereas descriptive statistics give us a sense of location, variability, and the nature of the distribution of the data in the sample. In other words, it gives us an idea of how the observations are varying from each other and how the distribution is. Is it normal distribution? Is it a chi-square distribution? So descriptive statistics helps us to know the nature of the distribution of the data in the sample. Understanding probabilities allows us to gauge the strength of inferential statistics. Probability is very important in that it helps us to know how strong inferential statistics is, because we use inferential statistics to make decisions about the population from where the sample came. As you can see, due to costs, we cannot select all elements in the population and conduct a survey or collect data on them. So, in order for us to save costs, we need to select a representative of the population, which is a sample, and we need to use inferential statistics, compute inferential statistics to help us make decisions about the population. And in order for us to do that, we need to understand the concept of probability. The figure showing the relationship between inferential statistics, population, probability, and the sample is as shown in this picture here. The sample along with inferential statistics allows us to draw conclusions about the population, with inferential statistics making clear use of elements of the probability. What is simple random sampling? As I shared before, when we select a representative of the population, which is a sample, we need to ensure that each of the elements being selected have equal chance of being selected in the sample. If there are other elements that have more chances of being selected in the sample compared to others, then the sampling is not random at all. In other words, it is biased. So, simple random sampling implies that any particular sample of specified size should have the same chance of being selected as any other sample of the same size. And we need to understand also other terms. For example, the sample size, which is defined as the number of elements in a sample that has been selected. And we also need to understand certain measures in statistics that are used to describe the sample. There are two examples. One is the median and the mean. The mean is supposing x1 is an observation, x2 is the second observation, x3 is the third observation, up to xn. Let be n observations in the sample. Then the sample mean mu is given by the sum of the observations from k equals to 0 to k equals to n of xi divided by n. This formula will give us the sample mean, which is equal to this to x1 plus x2 plus x3 plus dash 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 plus xn over what? N, which is the number of observations. The sample median for it is obtained by first arranging the n observations in ascending order, starting from the smallest value up to the largest value. Then you compute the median if certain conditions are specified. 1. If the number of observations is an odd number, then your median is the position of the total number of observations plus 1 divided by 2. This will give you the value of the median in that position. Whereas if the number of observations is even, then our median is going to be the average of the value at the position whose number is the total number of observations divided by 2 plus the value of the next observation So you'll get the average of those two observations, and then you divide by 2. So the average will give you the median of the value of the data set in that sample. The trimmed mean is the mean which is obtained by trimming away certain percent or both of both the largest and smallest values. For example, if you have your data set which is arranged in ascending order, if you remove some largest values, say 2 values you remove from the data set, and you get the average of the remaining values, you will definitely have a trimmed mean. Whereas if you can also remove the smallest values and the remaining values you use to compute the mean, still the result you get is termed the what? The trimmed mean. There are what we call measures of variability. This measures how observations vary from each other, or how are they distributed, or how are their values close to each other. Are they far apart? Are they close to each other? So such measures will help us to determine the variability of the what? Of the data set. Measures of variability, one measure is the range. The second measure is the sample variance. The range is defined by the difference between the maximum value and the minimum value. Maximum value given by x maximum and minimum value given by x minimum. The variance is defined by the sum of the observations minus the mean altogether squared divided by the number of observations minus 1, whereas the standard deviation is defined by the square root of the what? Of the variance. So we can use the range or the variance or the standard deviations to measure variability. If variability is low, that means that the variance also will be low, having a low value, or the standard deviation will have a low value, or the range will also be small. But if the variability is high, that means that we shall observe a bigger range, bigger maximum value, and smaller minimum value. So these indicators measures variability in the what? In the data set. We also need to understand the type of data. We have two different main types of data. We have the discrete data and then the continuous data, where discrete data refers to facts that takes absolute numbers on the number line, while continuous data takes facts on the number line which are real values. In other words, continuous data takes data